guys, so today we're going to get into probably one of the most important topics in regards to air conditioning and even just refrigeration. That is the refrigeration cycle. The refrigeration cycle is one of the most important parts in understanding how a air conditioner refrigerator work. This is the only way we can understand what your refrigeration gauges are telling you, why we achieve certain pressures and temperatures at a given refrigerant. And it also gives us a idea of how the overall operation of the internals of an air conditioner actually work. So by definition, the term refrigeration means cooling a space, substance, or system to lower and or maintain its temperature below the ambient limit, while the removed heat is rejected at a higher temperature. So really, what they're saying by definition of refrigeration is that refrigeration is artificial. It's human-made. We're using components to cool a space, a substance. Okay, air conditioning, we use refrigeration to cool a home or an office. We use refrigeration to freeze our food, to keep our milk cold. We use refrigeration for processing, manufacturing. Refrigeration and air conditioning is just simply taking, for lack of simple terms, is taking heat from a space where it is unwanted to a place it makes little or no difference. Refrigeration has many applications. Okay, we have it in our household, refrigerators, industrial freezers. We use it in cryogenics, okay, and our simple air conditioning systems. So for an air conditioning system, we have four major components that are in there. Okay, we have our compressor, we have a condenser, we're going to have a metering device, and we're going to have an evaporator. If any one of those components ain't there, you don't have a refrigeration cycle. It ain't going to work. You have to have all four components to have a refrigeration cycle. So let's start with the compressor, the role of the compressor. When I think of terms of the refrigeration cycle, the compressor is really the heart of the entire operation. That compressor has to run. It has to be on in order for the refrigeration cycle to do its job. It is the compressor that moves the refrigerant throughout the rest of the components. Okay? So, let's start at the very beginning. When refrigerant leaves an air conditioner's evaporator, it takes the form of a low pressure, low temperature, superheated vapor. We need to understand and keep it in our heads that the compressor only compresses. It moves the refrigerant through compression. Okay, so in order to release the heat that the evaporator has absorbed, that refrigerant needs to be in a higher temperature and a higher pressure. In HVAC, the higher the pressure, the higher the temperature. The lower the pressure, the lower the temperature. Pressure and temperature coincide with each other in HVAC. Okay, so in order for this to happen, for us to take that low pressure, low temperature superheated vapor and raise the temperature and pressure of that, we have to have the compressor. It is the compressor that takes that low pressure, low temperature, highly superheated refrigerant and it compresses it tightly together. And when I'm doing that, I raise that temperature. I raise the temperature of the refrigerant, both temperature-wise and pressure-wise. Once I am able to do that and I achieve that, that refrigerant is going to leave the compressor and it's going to now go to the discharge line on the compressor. The discharge line is going to be the smaller of the two lines. Right here on this Copeland scroll compressor, this is our discharge line. So refrigerant is coming in to the compressor through our suction line here, this line right here. It gets compressed and it gets shot out of that compressor as a high pressure, high temperature, highly superheated vapor. This line right here is going to connect to the condenser. The discharge line can be extremely hot. Okay, I know I have the scars on my hands and forearms from it, from working on units and accidentally touching that line. That line can get very, very, very hot. Okay, the reason why it gets really hot is because the refrigerant is being compressed through the compressor. That's all of that sensible heat, all that latent heat that the evaporator has absorbed, but the refrigerant is also picking up more heat. It's picking up more heat, and that is called the heat of compression. Okay, it's important to remember at this point in the refrigeration cycle is not only the refrigerant is picking up heat that the evaporator has absorbed, all of that sensible and latent heat that's in the space, but we are also picking up heat from the compressor as well. The compressor is a motor, guys. When it runs, it's going to heat up. We're using the refrigerant to act as a cooling agent to keep those motor windings cool. So that refrigerant, as it passes through the compressor, is picking up even more heat. So that line is going to get extremely hot. Okay? So in the addition of that heat, that refrigerant becomes highly superheated. We are now ensuring that the refrigerant is leaving the compressor. It is 100% vapor by having it a highly superheated state. Now, our discharge line is now connected to the condenser. The condenser is going to be located outside. Okay, the compressor is going to be inside our condenser coil. If I took this cover off and I look down inside, you're going to see the compressor. Okay, now the role of the condenser is where heat that was absorbed in the evaporator as well from the heat of compression from the compressor is now rejected to the ambient surroundings. Our ambient surroundings can be obviously air. This is an air-cooled condenser. Air has to pass through our condenser coil in order for the condenser to reject the heat from the refrigerant. Okay, the refrigerant enters the condenser as a high temperature, high pressure, highly superheated vapor. So as the refrigerant loses its heat, because now air is passing through it, it begins to cool off. And when it begins to cool off, it changes state. It's going to change state from that high pressure, high temperature, highly superheated vapor to a high pressure, high temperature, superheated liquid. Subcooled liquid. I'm sorry about that. Subcooled liquid. Okay? This is because the refrigerant is losing both sensible and latent heat. that was absorbed in the evaporator and the condenser. That point in the condenser where this change of state takes place is called the saturation point. That is the point in the condenser where this begins to happen. Okay, the refrigerant leaves the condenser as a high temperature, high pressure, subcooled liquid. As it leaves the condenser, it's connected to the liquid line. Okay, so here is a typical air-cooled condenser. So here is our discharge lines coming out of our compressor. It's coming to enter into our condenser as a high pressure, high temperature, highly superheated vapor. So as air is passing over that coil, I am now cooling off the refrigerant that is inside my condenser. And as I do that, it begins to lose heat. As it keeps going down, it loses more and more and more heat. So eventually what's going to happen is that high pressure, high temperature, highly superheated vapor will now turn into a high temperature, high pressure, subcooled liquid. As that happens, that point is called the point of saturation, or your saturation temperature. Okay, and as it leaves, it's going to now connect to your liquid line. Okay, so as you can see, we have 95-degree air coming in to our condenser, but yet it's leaving at about 130 degrees. That is all of that sensible and latent heat that is now being rejected from that refrigerant. It is that cooling action that we see. The liquid line connects the outlet side of the condenser coil and connects it to the metering device. So when you're looking at the outdoor unit, you're going to see two pipes sticking out of it. The smaller line, this is my liquid line. The larger line that usually has insulation on it, that's going to be my suction line. That's where the refrigerant actually gets returned back to the compressor. Okay, so here is my liquid line. The liquid line is going to be, or should be, warm to the touch but not hot. Okay, this is where we are at our high pressure, high temperature liquid, subcooled liquid. This line will now carry the refrigerant into the home to their air handler where the metering device is going to be located. So the metering device, as we see here, this here is actually a thermostatic expansion valve. That's what this guy is going to look like. This is the device that regulates the flow of refrigerant into the evaporator, setting up a pressure difference between the high inlet pressure refrigerant and the low pressure refrigerant in the evaporator. Okay, at the metering device, the refrigerant is converted. It's converted from a high pressure, high temperature subcooled liquid to a low pressure, low temperature subcooled liquid. When I think about the metering device, I like to think of it like a traffic cop. It's only going to allow so much refrigerant through. And when that happens, I create a pressure difference. That pressure difference is going to cause a flash gas. It's going to cause that refrigerant to drop in temperature. Because remember, temperature and pressure coincide with each other. It regulates. So as it's regulating, it's going to drop the pressure on my outlet side. So my refrigerant is coming in to my metering device. The metering device is going to decide how much refrigerant is going to come out. So when that happens, I am now allowing the refrigerant to kind of expand. And when I have that expansion, I now am able to take that refrigerant and lower the pressure and lower the temperature, where I can now enter the evaporator. Okay? Flash gas occurs because of that sudden drop in pressure on the outlet side of that metering device. Usually in air conditioning systems, you're going to have 3 types of metering devices that you're going to usually find. You're going to have a capillary tube, which is going to be found in a lot of like your window units, maybe some PTAC type units. You're going to have a fixed orifice or piston type metering device. You're going to find those in a lot of your commercial and residential central air systems, or your TXV, or better known as your thermostatic expansion valve. You're going to find those in your residential and light commercial units, rooftops, things of that nature. So the role of the evaporator is, this is where the heat is going to be absorbed in the space that we're trying to condition. Okay, the evaporator is going to be usually located inside the air handler, inside the home, and usually going to typically look like this. Okay, the metering device will actually be located right here in this picture here. The metering device is not installed, but the metering device would be actually located right here. This is where that refrigerant will actually come through and then distribute the refrigerant to either side of the evaporator, where now that heat can actually now be absorbed as the air passes through the coil. So the refrigerant enters your evaporator as a low pressure, low temperature subcooled liquid and begins to boil or evaporate, turning into a low pressure, low temperature superheated vapor as it's absorbing heat as it passes through the coil and changes state. Okay, the boiling point is determined by the pressure in the evaporator. Okay, the refrigerant leaves the evaporator through the suction line and then heads back to the compressor. Your suction line is located right here. This line is going to carry that refrigerant back through our suction line and then back to the compressor. So we can divide the refrigeration cycle into a high side and a low side system. That division takes place between the compressor and the metering device. The condenser is on the high side of the system. The evaporator is on the low side of the system. It's important to know that. It's important to understand the difference between those two areas so that we can honestly troubleshoot each component. We know that the condenser is going to be a high pressure, high temperature refrigerant. The evaporator is going to be a low temperature, low pressure refrigerant, which is why you have refrigeration gauges. Your refrigeration gauges is made up of a red gauge and a blue gauge. The red gauge is for our high side pressures. The blue gauge is for our low side pressures, or evaporator pressures. So here we are. Here is our system component layout. Here is our compressor. This guy has to run. Okay, the compressor is running. We have our discharge line, our compressor outlet. High pressure, high temperature, highly superheated vapor is now traveled into the condenser, where now that condenser now begins to reject the heat. As it rejects the heat, that saturation temperature or saturation point begins to take place, where that high pressure, high temperature, highly superheated vapor turns into a high pressure, high temperature subcooled liquid. As it exits the condenser, it is now carried through our liquid line. In some cases, you will find a filter dryer in there. The filter dryer is there to remove any sort of debris or maybe even moisture that may be in the refrigerant. You may or may not see them. It depends on the unit that you're working on. It now travels to your metering device. The metering device is the traffic cop. it is now only going to allow so much refrigerant through. It regulates. And when that happens, I am now able to drop the pressure. And when I do that, I am now able to allow the refrigerant to expand. And by doing so, I am now able to have a low pressure, low temperature, subcooled liquid enter into my evaporator, where now my evaporator now begins to absorb heat as air is passed through it. And when that happens, I begin to change state from that low pressure, low temperature subcooled liquid to a low pressure, low temperature superheated vapor. So again, here is my saturation point, again, where my refrigerant is now changing from a liquid to a vapor. As it exits my evaporator, I am now 100% low pressure, low temperature, superheated vapor, where it is now traveling back through the suction line to the compressor, where that refrigeration cycle just keeps going around and around until the thermostat satisfies. So here we are, your system components on your high and low side. There is my dividing line, my compressor and my metering device. Everything on my condenser and metering device, that is my high side. My liquid line, everything, my metering devices on my high side. Everything on my evaporator and back to the compressor, that is my low side. I can also divide my refrigeration cycle into my liquid and vapor side. Everything on my outlet side of my condenser, which goes to my metering device, that is all liquid. That's my liquid side. Everything from the outlet of the metering device back to the compressor, that's all vapor. And everything from the outlet side of my compressor to my condenser is also all vapor. Okay, so just in review, some mechanical sequence of our refrigeration cycle. Again, starting at the outlet of our compressor. The outlet is our discharge line. At the discharge line, a high pressure, high temperature, highly superheated vapor passes through the discharge line to the condenser. The high pressure, high temperature, highly superheated vapor travels through the condenser, and heat is rejected, causing the refrigerant to change state to a high temperature, high pressure subcooled liquid. The liquid refrigerant travels to the metering device through the liquid line. The liquid is then metered into the evaporator. Due to the sudden pressure change, a small amount flashes into a gas rapidly. The liquid has begun to change state and is now at a lower temperature and pressure. As it passes through the evaporator, the refrigerant absorbs heat, and as it absorbs heat, it boils and changes to a low pressure, low temperature superheated vapor. Refrigerant then returns to the compressor through the suction line, thereby completing the entire refrigeration cycle.